like I said, we're going to go over this post-lab density is a periodic property. So let's start off with just talking about a couple of things. I'm going to show you my next slide here. And on this slide, we're going to go over a few things that I've seen people commonly losing points on. First of all, it's obvious that I'm going to be constructing a graph here. So when we're dealing with the density of a periodic property, I need to have a title on my graph that is descriptive. Okay? Now that title should have something to do with the dependent and the independent variable. Okay? The dependent and the independent variable, which is located on the x and the y axis. I always used to teach my biology kids, dry mix. Dry mix. D is dependent, has the y with it. Okay? So the dependent is on the y axis, and the mix, the independent, is on the x axis. All right? So when I'm talking about these and I have a descriptive title. Now, my descriptive title is not density of elements, is it? Okay? So it has to do with, and my very, very descriptive title is the effect of increasing periods of the carbon family on the density of an element. So I have density now here on my y-axis. Notice that I have density and I have a label with density. All right, a lot of people put density, but they didn't have a label. They lost a point for not having a label. Down here, I don't think I took off for not having a label like the number here. Okay, so if you just had period, I don't think I took off on your points there. But those are certain points that you can get on your graph. Typically, the x and the y-axis are both 2 points, and the title is 1 point. So that's 5 points already on your graph, and you haven't even done anything yet. All right? So let's make sure that we have all of those things taken care of. Second of all, when we have our different numbers down here at the bottom on the x-axis and my numbers right here up here on the y-axis, okay, we have to have intervals that are the same. I can't be skipping intervals. All right? What I mean by that is, let's say when I'm doing my period number, I'm going to say that every 3 boxes are a new period. Okay? So I have common grounds there. Every 3 boxes are a new period. I saw some people doing this. Okay? They said, all right, here's period 1, here's period 2, here's period 3, here's period 4, here's period 5. Okay? Is your graph going to be legit like that? I have different intervals. Each interval here is 1, and now here 2 is 1, 2 boxes in 1. Here 3 boxes is 1 period. That's not going to give you accurate data, and I saw some people doing that. So what I chose to do is, like I said, I'm going to make every 3 boxes a period. Does it matter here on the front like that? Just so I have 3 boxes, it doesn't matter. Okay, that's legitimate. That's a legitimate one there. Now, I have 14 boxes up, and I have a range right here between 2 and 11. So what I'm going to do is I'm just going to have each box be 1. So I'm going to have 0 there, 5, 10, and my top one's going to be 14. So I have definitely plenty of available spaces to make my range between 2.2 and 11. Now, as I'm looking at this, I am going to plot my data. Well, let me first go back. If I have my number right here, okay, each box is 1, correct? Where should my estimated value be when I'm reading that scale? Carly? The 10th place, okay? Because let's say I'm right here where my arrow is, okay? I'm right here where my arrow is, right there. I know that that's 3. I know that that's not 4. So I am going to estimate somewhere in between 3 and 4, and that's going to be at the 10th spot. So the more accurate, the more spaces you have on your graph, perhaps the more accurate you can be on your measurements. I'm going to look at this, and I'm going to plot my numbers now. For period 3 is silicone, I have 2.2. So I have 1, 2, 2.2. I'm going to say is right here. Period 4 is where I'm trying to find germanium. Period 5 is 10, and it's 7.2. So 1, 2, 3, 4, 5, 6, 7.2. About right there. And lead is 11. So I find my lead. I'm going to put it on 11. I think I'm going to change that too. I probably really should have had 11.0 for that one, since I have 2/10 on all those. So what I'm going to do now is I'm going to construct a best fit line. Now, I'm not going to use my yards or my meter stick here, because once I hit my meter stick on the screen, it changes the screen. All right, and I'm not good enough yet. Does anybody know how to make a line on a smart board? Like a computer make it? Can you do it? What happens if I right click? Nope, I don't want to do that. So I'm just going to draw in a best fit line. It's not going to be straight, and it's going to be crazy for me because I'm OCD and I need straight lines on my graphs. But nonetheless, I just went through there and I made my best fit line. Now, by looking at that, now I'm going to come up to my 4, and right there is my period 4, and that looks to me like it's 5, and I'm going to say it's exactly on that 5.0 line. So I estimated. That 0.0 tells me that I am estimated it is exactly on the 5 line. All right, so I come on now to my next slide. Well, here, the theoretical value. The theoretical value for germanium on the periodic table is 5.323 grams per cubic centimeter. Remember, a cubic centimeter is the same as a milliliter, so I'm still okay with my labels. So I need to calculate my percent air. Okay, I want to calculate my percent air, so I am going to take the experimental that I just got, that 5.0, and subtract it by the accepted value. Okay, so as I go through and do that, my value here was 5.0. So when I take those values, I am going to get a negative, but since I take the absolute value, it's going to take that negative away. Now, sig fig wise, I see that I have 10th and I have 1,000th. So where do I need to round this since I'm adding and subtracting? To the 10th. Okay? So this value I'm going to have for right here is going to be 0.3. Now, I am going to then divide that by my theoretical value, which is the 5.323, and I'm going to multiply that by 100. So as I do this, 0.3 divided by 5.323 gives me a value. Multiply that value by 100, and I round it to 1 sig fig, and I get 6% error. So, based on what I've told you about our accuracy in experiments, what do I want to try to find with my accuracy? What range do I want it under? 5%. So did I hit this? I'm pretty close, but I didn't hit it. Okay? I'm pretty close, but I did not hit my 5%. I'm going to say that's all because of that crooked best fit line that I drew. All right? If I'd have had a straight edge, it would have been better. All right? Any questions about what I just did there? Make sure when you are doing a graph, that you have all the labels. Those are easy points you should be getting.